Today we will discuss PMI, that is Principle of Mathematical Induction. This chapter is based on method of induction. Okay, so by the method of induction we prove the questions here, and this technique is entirely different from other questions. Okay, whatever questions you have seen in other chapters, this is totally different from that. So let us understand what it is. If you have not subscribed my channel, do subscribe it and share it to others. Okay. This method says that some statement is given to us. Here n is natural number, and this statement is true for n is equal to 1 if we can show that Pn is true for n is equal to k, and this thing implies that Pn is true for n is equal to k plus 1 2. It means whenever this statement is true for n is equal to k, it means some fixed natural number. Then if we can prove that this statement is true for n is equal to k plus 1 2, then we say by principle of mathematical induction that this statement Pn, the given statement Pn, is true for all n belongs to n. It means for each and every natural number this will be true. It means entirely up to infinity we can go. So this is always going to be true. Let us understand this method by an example. Statement Pn that 1 square plus 2 square plus 3 square plus dot 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 plus n square. This value is equal to n plus 1 2n plus 1 whole upon 6. This statement is given to us, and we have to show that this is going to be true for each and every natural number. Okay, it means we have to show it for infinite numbers. Okay, but we are not going to prove for each and every number. We are going to prove for only few steps. Okay, according to the PMI method. First step is that for n is equal to 1, we see for n is equal to 1 what happens. So what are we going to do? Okay, in this variable n we are going to put n is equal to 1. Fine. So what happens? Which term we get? We get this term. Fine. So we will be limited to this term only, 1 square. In the RHS we are going to put n is equal to 1. So we get 1 plus 1 2, 1 into 2 2, 2 plus 1 3 whole upon 6. Now simplify, 2 and 3 become 6. So this is 1. So LHS also 1, RHS also 1. So 1 is equal to 1. This is a known fact, it is a true fact, everyone knows. It means we say that this statement Pn is true for n is equal to 1. Okay, this is our conclusion from this step. Now to understand the method, let me do it for one more time. Okay, let me take one more number, n is equal to 2. Suppose we are checking for n is equal to 2, then let us see what happens. So we are going to put n is equal to 2 here. So what happens? This value comes. So we will add first term as well as second term. So this will be 1 square and 2 square. Okay, these two terms will be combined. Fine. Now RHS we are going to put n is equal to 2. So 2 plus 1 3, 2 into 2 4, 4 plus 1 5 whole upon 6. Okay, so 2 3 are 6, cancel. So this is 5, and here it is 4 plus 1. We know 4 plus 1 is 5. So LHS RHS both are equal. So it means we can say Pn is true for n is equal to 2. Okay, this I have just shown you. Okay, many times in the solution we do not do this kind of a step, but I have done this step just to make you clear, okay, what it is, what the method is. Suppose in this manner we keep on putting n is equal to 1 2 3 4 and so on. Okay, it means for each and every natural number if we try to prove it, then certainly it will be true for some n is equal to k. Okay, and this k is natural number. So in the next step, let Pn is true for n is equal to k. Okay, and here k is what? k is any natural number. Fine. So for some natural number this will be true. Now let us assume if this is true for n is equal to k, so it means we can put n is equal to k in the given statement. So let us put 1 square plus 2 square plus 3 square plus so on plus n square, it means k square is equal to, here also we will put n is equal to k. So k plus 1, 2k plus 1 whole upon 6. Put this equation 1, then this becomes 2. Now our main task is left. Okay, only one step is left. If we can prove that this statement is actually true for n is equal to k plus 1 also, okay, then it will be proved that this statement is going to be true for each and every value of natural numbers. Okay, it means infinite natural numbers ke liye this will be always true. Okay, so we will prove for n is equal to k plus 1. If this value we are putting n is equal to k plus 1, then what happens? So 1 square plus 2 square plus 3 square plus and so on plus k plus 1 whole square, this entire value is actually equal to k plus 1 and then k plus 1 plus 1, it means k plus 2 and then 2k plus 1. Okay, so what is 2k plus 1? This is 2k plus 2 and plus 1 is already there, so this becomes 2k plus 3. So 2k plus 3 it upon 6. This we have to prove. Okay, anyhow ये result हमें prove करना है. Now how can we prove it? Let us see. So from equation 2 what we do? We can add k plus 1 whole square. Only this term is not there. Okay, so before that we know k square will also be there. So from here till here each and every term is there in equation 2, but only this term is not there. Okay, so what we do in equation 2, we will add k plus 1 whole square in LHS as well as in RHS. Okay, so from equation 2 okay, this value is already there. What are we going to do? We are going to add this term in both the sides. So this becomes k plus 1, 2k plus 1 whole upon 6 plus k plus 1 whole square. Now what happens? This term becomes LHS, whatever we have to prove. Okay, we have got. Now RHS we have to show this. Okay, k plus 1, k plus 2. So k plus 1 is already there, so we will not disturb this. Okay, so k plus 2 and this value should be there. So let us simplify. So can we take something common? K plus 1 is common. So after taking common we get k and 2k plus 1 whole upon 6 plus k plus 1 upon 1. Now we have to simplify this. Let us take LCM 6. So 6 into this, it means 6k plus 6. Here it becomes 2k square plus k plus 1, and this becomes 2k square plus 7k plus 6 whole upon 6. Fine. So can we factorize this? 6 into 2 becomes 12. 12 has factor 4 and 3. Okay, 4 into 3 becomes 12 and 4 plus 3 also becomes 7. So this term can be factorized 2k square 7k plus 6. So 6 to the 12, 2k square plus 4k plus 3k plus 6. Fine. This is just a splitting middle term method which we discussed in class 10th. So we are going to use this. Now take common. We have 2k common. So what is left? Only k is left here. Here only 2. So from here take 3 common, k plus 2. Okay, this value is same. So take this value common. So we get 2k plus 3. So in next step we can write as k plus 1, k plus 2 and 2k plus 3 whole upon 6. LHS is also the same, RHS is also the same. Okay, so it means what can we deduce? This we can do in rough. Fine. Therefore we can say that Pn is true for all n belongs to n. Okay, it means Pn will be true for each and every natural number. Okay, so this is the method. I hope you have understood. Let us do one more question to make the concepts clear. Now this next question can come in three forms. For all these three forms, okay, the same solution works. So let us see the first step of the solution. Okay, we put n is equal to 1. So what happens when we put n is equal to 1? So we get 7 to the power 1 minus 3 to the power 1. Okay, this is our P1. Fine. So what happens? This is 7 minus 3, that is 4. So we can say that P1 is divisible by 4. Okay, or we can also say that P1 is true. Like this also we can say. Now next step, let Pn is true for n is equal to k. The previous question I took for n is equal to 2 also to make you clear what the working is. Okay, so here the procedure is after n is equal to 1 we can quickly jump to n is equal to k, and then we can prove for n is equal to k plus 1. It means we say that 7 to the power k minus 3 to the power k is divisible by 4. Okay, so this is equation 1 and this is equation 2. You can say now this value is divisible by 4. Now what we have to do, we have to prove for n is equal to k plus 1. You can also call this is pk. Now what is pk plus 1? Let us see. So it will be just replace k by k plus 1. So this becomes 7 to the power k plus 1 minus 3 to the power k plus 1. We need to simplify. We can take use of equation 1 and equation 2. What can we do for this? Let us quickly think. So here the power k is there, 3 to the power k, and here the power is k plus 1. Okay, if their power is k, then we can do something. So first of all, let us simplify it to power k. So this becomes 7 minus 3 to the power k into 3. Okay, now this bigger number, can we split this number into two parts? Just think about it. We can write this 7 as 4 plus 3. A student can also say, sir, we can also write 7 as 6 plus 1, 5 plus 2. Okay, why we took 4 plus 3 only? Okay, so there is a reason, there is a logic, that's why we took it. Okay, and just give few seconds, after few seconds you will understand the logic. Now open this 7 to the power k into 4 plus 3 into 7 to the power k. Fine. So we have got these terms. Now this is what 7 to the power k minus 3 to the power k. Can we get this expression somewhere? Just think. If we take 3 common in these two terms, can we get similar expression? Yes. Okay, and that is the key, that is the reason why we have split this 7 into 4 plus 3. Okay, we could easily write 5 plus 2 or 6 plus 1, etc., but we took this value only. Okay, this you have to think. This is only the critical step for the question. So this becomes 7 to the power k into 4 plus 3 common 7 to the power k minus 3 to the power k. Okay guys, so this value we already know by equation 2 that it is divisible by 4. Let us say that 7 to the power k minus 3 to the power k is equal to 4 into natural number, 4 lambda, where lambda is any natural number. Okay, 4 lambda. So we are putting this value here. This becomes 7k into 4 plus 3 is already there. This is 4 lambda. Okay, we are putting this value. You can say equation 3 if you need. So from equation 3 we put the value. Okay, now can we take 4 common throughout this expression? Let us see. We have taken 4 common, so this becomes 7 to the power k plus 3 lambda. Okay, so whatever is inside, this will be some positive integer only, fine, or some natural number, but we require to prove this 4. This 4 is our main task. Okay, why it was main task? Because we have to prove that the statement is divisible by 4. Okay, we know that if any value has a factor 4, okay, has a factor 4, then obviously it will be divisible by 4. Okay, so that is the main thing which we have proved here. Okay, so here we can say therefore Pn is true for all n belongs to n. Okay, some students write after this step that p k plus 1 is true. Okay, you can write, no problem, there is no issue. You can also write that p k plus 1 is true, and after that you can write this statement. Fine. I hope the method is clear to you. Okay, now let us do one more critical question to make the concepts more clear. In this question, Pn is given like this, and we have to prove that this statement is divisible by 8. So let us do it for n is equal to 1. Okay, what happens? Pn becomes 3 to the power 2 into 1, that is 2, 2 plus 2, 4, minus 8 into 1 means 8, minus 9. Okay, we know 3 to the power 4 is how much? 81. So this is 81 minus 17. How much is this? Subtract. This becomes 64. This becomes 64. Therefore, we can say P1 is divisible by 8. Fine. Hence, P1 is true. We can also write that Pn is true for n is equal to 1. Both are the same thing. Pn is true for n is equal to k. This statement is true. We have to assume. So what happens? This becomes pk. This is 2 raised to 3 to the power 2k plus 2 minus 8k minus 9. This value is divisible by 8. This we have assumed. So equation 1, equation 2. Okay, this is our main step. So we can always write that this entire value minus 8k minus 9, this value is equal to 8 into lambda, where lambda is what? Any natural number. Okay, so if students feel fear with the lambda, they can take any other variable, okay, which they feel convenient, but the variable should not be included in the question. That is the main condition. Now this thing is known to us. Now what we have to prove? We have to prove that pk plus 1 is also divisible by 8. So let us find pk plus 1. So we will put n is equal to k plus 1. So 3 to the power k plus 1 plus 2 plus 8 times k plus 1 minus 9. Now let us simplify. This becomes 3 to the power 2k plus 2 and plus 2, it means plus 4. And here it becomes 8k plus 8 and minus 9. Now in such questions, what I told you, okay, whatever steps you have got, you have to use those steps anyhow to prove your result. Okay, what is our result? What is our requirement here? We have to prove that pk plus 1, it means this RHS, entire RHS is divisible by 8. Okay, so we have to take out 8 factor anyhow. Many more tricks can be there. Okay, one more trick I want to show here, okay, which will help you a lot in these questions. So here, if it is not easy to take out this entire term, okay, if it is not easy to make this entire term over here, you can substitute the value. Suppose this is a bigger term, you can substitute this value. This value will be 8 lambda plus this. Okay, or if you get this 2 terms, then also you can substitute the value. So let us see which term we have got. This can be written as 3 to the power 2k plus 2. Okay, this plus 2 can be written as 3 to the power 2. Now plus 8k plus 8 and minus 9. Do not subtract here. Okay, just wait for few seconds, because we are going to get this entire term. We can also take 9 also, because these 2 terms we can easily see. Okay, this term is visible here, this 9 is also visible here. This 3 square is how much? It is 9. 9 we know can be written as 1 plus 8. Okay, now you will say, sir, why 9 is 1 plus 8? Because it is required here. Anyhow we need to insert 8. If we write this 9 as 1 plus 8, then easily we can get the factor 8. So this becomes 2k plus 2 into 1 plus 8. Okay, plus 8k plus 8 and minus 9. Okay, now simplify. This becomes 3 to the power 2k plus 2. We can keep this 9 over here. So minus 9. Now this 8 into 3 to the power 2k plus 2. And next term we have 8k and plus 8. Fine. So what we have done, we have opened this bracket and we have kept this minus 9 here with the first term. Okay, why I did this? Because see equation number 3, we can get the value of these two terms. Okay, from here, what is the value of these two terms? Easily you can see 3 to the power 2k plus 2 minus 9 is equal to this 8k can be shifted over there. Fine. So this becomes 8 into k plus lambda. Okay, so at this place we can put this value. So let us put the value here. This is 8 times k plus lambda plus, take 8 common here, 3 to the power 2k plus 2 plus k plus 1. Now we see 8 is common here also, it means 8 is common everywhere. Finally you can write after this is equal to 8 into this entire expression. This entire expression you can write. So k plus lambda plus 3 to the power 2k plus 2 plus k plus 1. Fine. So we can see 8 is common in the entire expression. So what we see that pk plus 1 is divisible by 8. Okay. Therefore Pn is true for all n belongs to n. It means everywhere this statement is true. Okay, for each and every natural number it is true. Fine. So guys, give your comments about this video and share it to maximum students so that they can get the benefit. If you have any doubt left regarding the topic, feel free to ask it. So we will meet in the next video. Till then, goodbye, take care.